Hello there, I am Cherilyn M. Otos from BSN Sciences. Today, I am going to report all about potential wells. What is potential wells? Potential well is a potential energy function U x that has a minimum. In Newtonian mechanics, a particle trapped in a potential well can vibrate back and forth with periodic motion. Our first application of the Schrödinger equation, the particle in a box, involved a rudimentary function well with a function that is zero within a certain interval and infinite everywhere else. So this function corresponds to a few situations found in nature, but correspondence is only approximate. A better approximation to several actual physical situations is a finite well, which is a potential well with straight sides but finite height. The picture shows a potential energy function that is zero in the interval and has the value outside this interval. So this function is often called a square well potential. So the square well potential, it could serve as a simple model of an electron within a metallic sheet with thickness L, moving perpendicular to the surfaces of the sheet. The electron can move freely inside the metal but has to climb a potential energy barrier with height to escape from either surface of the metal. The energy is related to the work function in connection with the photoelectric effect. In 3 dimensions, a spherical version of a finite well gives an approximate description of the motion of protons and neutrons within a nucleus. In Newtonian mechanics, the particle is trapped or localized in a well if the total mechanical energy is less than in quantum is less than. So in quantum mechanics, such as trap state is often called a bound state. All states are bound for an infinitely deep well and for a finite well like that is shown in the picture. If it is greater than, the particle is not bound. A potential well is present in a particular region of space due to a action of a force in that region of space. The force acts on particle within that region, and so this requires a given particle to do work. Against the force, if it is to carry on along its original trajectory. If the particle has less energy available to it than the energy required to overcome the force acting on it, like the kinetic energy, and that is its kinetic energy is less than the potential energy associated with the force, then the particle will be trapped in the potential well. That is to confine to travel within the region in which the force is acting along trajectories prescribed by the action of the force. If the particle's kinetic energy is greater than the potential energy, or it is associated with the force, then it won't be trapped in the potential well and will be able to escape the region of space in which the force is acting. As an example in simple harmonic motion, or SHM, A spring is subject to a restoring force of X is equal to negative kx, and this has an associated potential V is equal to 1/2 kx squared. The potential well is static, with the minimum describing the equilibrium configuration of the spring. The spring then oscillates about the minimum of the potential compressing as it moves up one side of the potential, hence gaining potential energy and losing kinetic energy. Then, moving back to the minimum of the potential well, it loses potential energy and gaining potential energy. And then stretching as it moves up the other side of the potential, again gaining potential energy and losing kinetic energy. It then repeats this in an oscillatory fashion. A potential well is basically the energy required to be in a certain position. For example, if you have a hole and a ball in the hole, it will require a certain energy for it to get up and out of the hole. However, if it does not have that energy, it's stuck at the bottom of the hole. And that's the end of my topic. Thank you. Potential well. The potential well is a region of space where a local minimum of the potential particle energy is present. The Schrödinger for the particle inside a finite potential well becomes 0 less than x less than L. The particle cannot exist outside the box as it cannot have infinite amount of energy, thus its wave function is between 0 and L, where L is the length of the side of the box. In a finite potential well, the potential energy outside the box is variable. Its explanation is that in a finite potential well, the potential energy of the particle outside the box is finite constant, unlike infinite potential well, where the potential energy outside the box was infinite. And that's the end of my topic. Thank you for watching. Have a great day.